So, hey guys, and welcome to our next live session. So, this is our live session on YouTube today on 16th of July at 9:30 p.m. Today, we're going to go through a few programs that are commonly expected, whether you're going for Infosys interviews or for TCS Digital or NQT. These sort of questions, that is coding programs you can generally expect when it comes down to interviews, and if you do go through these programs, it's gonna definitely help you through when it comes down for you to go through as well as clear technical rounds, because we know whether it is TCS or Infosys, all these companies ask coding questions with somewhere around 30 to 45 minutes per question, and we need to answer the question within that limited time. So that's what we're going to focus on. So let's do that without any delay. So good evening and welcome to this live YouTube's interactive session with all of you guys. If you all can hear me properly and see the screen, you guys can just hit a message in live chat stating AV, or you can hear me and see the screen properly, and we'll just begin right away. So Rajat sir is doing well. He'll be taking the classes as well, pretty good. Not to worry. Sir's doing really well. All right. So let's go ahead and continue from where we left off in the last session. So today we're going to go through a very important question. We're going to go through a very important problem that's called finding the peak problem. So this particular problem that you're going to see today is going to remind you something that we learned back in first year of engineering when we went through C language lab, but it's going to remind you more than that. It's going to show you how we can use some basic techniques in order to create or in order to solve some complicated programs in the shortest time possible. So there's going to be a lot of let's say a lot of emphasis in the next program that we're going to do, particularly on time complexity, as to how we can solve some programs with less than big O of n time complexity. So that's what we're going to go through to make sure that you're going to be able to answer some programs in the best way possible. But before that, we have one of the programs which we still have pending. If you guys remember, that is conversion of our hollow diamond problem, which we did into Python. Now let's quickly do this under 5 minutes. Let's not try to take too much time because we have already done this code. For those who are joining for the first time, you guys can definitely go through our previous video. We have a playlist of these, and check out what was the problem that we did and find a solution, because the same problem we're converting into Java in a quick time and quickly moving or converting to Python in a quick time and moving on to our hugely important problem, that is the peak problem. So let's quickly do this. First thing is we just need an integer. Once done, we just need a string. So once we have read the integer and a string, we're going to directly go ahead over to the next part, that is call our print pattern function. That's it. When we go to our print pattern function, we need to just read the string and end. Now, many of us may not realize this. You don't have to compulsorily read them. You don't have to compulsorily read these values, because, hold on guys. So going on here, here's the basic thing. As we were pointing out, you don't have to compulsorily send these values and receive these values, because they are global variables. Since they are global variables, you really don't have to worry about them. You can just not even receive them. You can still access them. But if you want, you can receive and work through them as well. These are some little things which many of us don't realize when it comes down to Python. So what we'll do here is take this Java code, whatever we have. Let's quickly take it up and quickly convert this over to Python without much delay. So let's observe if we have copied only the content. Yes, we have. Now let's write it over here. Now let's note this. It's really not going to be a difficult thing. Don't worry. It's really not going to be a difficult thing. It's going to be a very, very easy thing. Let's see if I can. Okay. Okay, I've just reduced the tab spaces. All right. Now, we don't need to declare other variables because in Python, we really don't need to declare them separately. It's going to get declared the moment it's created. So only s equals 0 is what we need to declare separately. The rest all, let's just remove them. The rest as it is, let's just keep it as it is. Remember, right shift also works in Python. So you don't have to um, change the code for that purpose in any way whatsoever, because you do have uh, all your bitwise operators that are expected as well. And we're just going to take the length, and there's only one difference. To calculate the length, we just need to use len of string. That's it. That's the only difference. So once we do this, we can go ahead and work through the same lines as before. Now remember, we have read this as a string, so we can access indices. Unlike Java, where string is an object of string class, in Python we can access indices. So we're just going to use this particular for loop here, and comment line is different here. So for 1 to n1, so I in range of 1 to n1 plus 1, because n1 should be where it stops. So that's what we're gonna do here. So let's remove the brackets, the closing bracket as well. Let's just remove it for the same purpose, which is here. Done. Sorry guys. Okay, done. Now let's go on very quickly. Now here we have one more loop, that is to go through j value until some line. So here to replace this, I'm just going to use for j in range of 1 comma, again as usual, whatever is the value here, you need to add 1 and write it. So it's basically n1 minus I plus 2. That's it. So once you have done that, you just need to print some particular value, and let's just try to figure out what is it that we're going to print. We're going to have to print str of s. So we're just going to write print of str of s, and you need to write end equals nothing, because by default Python will end a statement using new line character. You shouldn't use new line character in this case, so that's why we can use this. And also when you perform modulus, you're just storing the result back in as same thing. Now let's go on for the spaces. This is done. Okay, we need to remove this line we hadn't removed. Done. Now for each line initially stars are done. Now let's go for spaces. Simple logic again. For j in range of 1 comma 2 times I minus 2 instead of minus 3, because that's the stopping range, stopping criteria. That's it. And we just have to do the same thing. We're going to take the same print statement, but instead of str of s, we're just going to write end equals space. Each time it's just going to print a space. That's it. So you don't even have to specify anything. You can just say end equals space. Now let's go for the last one, that is print some stars. Now we have multiple conditions. If we are in first line, we have a separate scenario. If we are in other lines, we have a separate scenario. So first line, we're going to repeat from for I in range of 1 comma n1. I think one of you had particularly asked for this program. Was it Prasan who had asked for the Python program particularly? I'm assuming so. So I'm going to copy the same code as we have here, no change. So I'll just copy paste here. So that solves our for loop here, which is done. Then our else condition, let's take this up here again. It's the same logic, but this time it is n1 minus I plus 1 rather than just n1 minus I. So let's take this scenario. This time I'm going to work it out as n1 minus I. That's the only scenario, only difference. Rest all are exactly the same. We really don't need to change them. We really don't need to worry about them. So to go to next line, we can just use an empty print statement, because when you print nothing, by default end goes to new line character. When end goes to new line character, it just goes to next line by default. Now let's quickly take up the lower pyramid. Again, here we have a loop from 1 to n2. We'll use for I in range of 1 comma n2 plus 1, because n2 is the stopping criteria. Here we're going to print this, and let's go for the J loop. All right, so let's go for the J loop over here. Again, we're gonna do the same thing. So this time we are repeating till I plus 1, right? So we have to increase by 1 again. So for J in range of, let's just take a look at this again. J to 1 to I plus 1. So for J in range of 1 comma, so let's all right, sorry. So let me write it down here. For J in range of 1 comma I plus 2 here, because I plus 1 is the stopping range. So this is how we just need to change it. Really not much of a difference. Simple logic. Really not much of a difference. So let's go for the last spaces part here. Again, here the same thing. For J in a range of 1 comma, this time it is 2 times n1 minus 2 times I. Instead of minus 3, what should I write here? Think of this. This is my question to all of you in the live chat. Should I use minus 3 or should I change it to something else based on what we have learned so far? We have the scenario where we are starting from 1 until the stopping criteria. This is the value where we are stopping, right? So if you're stopping at 3, then of course, absolutely right. We should use 2 over here. That's the basic logic. Here we're just going to use the same print statement where we're going to write end equals a space. That's it. So once this is done, we have solved this particular logic as well, this particular problem as well. Let's go for the last case, that is print stars. Now in this last case, we have again 2 scenarios. That is one scenario if we are in last line where we need to write for J in range of 1 comma n2 plus 1, because the stopping criteria is n2. And we're going to print the same thing as we did earlier, same thing. Else, we're going to write again the same logic, but this time I plus 2 for J in range of 1 comma I plus 2. Let's quickly do this, because once we do this, we'll quickly go ahead for our very important problem, very special program that we're going to solve today as quickly as possible. So let's go ahead, and finally we need to go to next line, for which we're just going to use an empty print statement. Done. That, and the last line is also removed. So let's see if it does work. I'm expecting we may find some errors because we have quickly tried to convert them. If we have, let's see where to debug them. Let's try Python 3 code.py. So that's one small mistake. Code.py. Let's give an input like 7 and a string called Jack, and we are getting this. Now, is this right? There's one little problem that occurs here. There's something wrong when it comes down to whatever we're printing here. So in the first loop, if you guys observed here, in the first loop, second loop we have absolutely no problems. That's perfect. In the first loop, we have some problems, especially when we start with space. So let's try to compare this. In under a minute, let's quickly do this without taking too much time. So what do we have here? For first loop, we have to repeat till n1. So we are doing that. Done. So let's take the next inner loop. For j equals 1, j less than n1 minus I plus 1. So if it is up to n1 minus I plus 1, my logic here should be up to n1 minus I plus 2. That is also perfect. Now let's go for spaces. Spaces here is 2i minus 3. What have we used? 2i minus 2. So that should also work well. Perfect. Now let's look at the last scenario. If I is 1, otherwise. If I is 1, we're supposed to repeat till n1 minus 1. That means I'm supposed to keep the final scenario as n1. But in the other case, it is supposed to be n1 minus I plus 1. That means our scenario should be n1 minus I plus 2. What we have done here is n1 minus 1. So this is supposed to be n1 minus I plus 2 instead. That's the only difference. Let's try running it this time. 7 and Jack. Now we should get it right, and we have. So this is our simple Python program which we were able to do in under 10 minutes by just taking up the code that we had earlier. So this is your Python code for hollow diamond problem. Now, once we are done with this, let's quickly go ahead and try to go through our major problem now. This is where we're going to go through the most important part. This is where we're going to go through the big problem that we're going to solve. So this problem is called find peak. Let me explain what exactly this means. And I'll give you conditions. I'll give you constraints which will make it difficult to solve. That's our whole idea, right? We need to find the best method. So I'm going to give some constraints. So take a simple array like this. I'll give you a scenario. Let's say 1, 2, 1, 3, or I'll just take four values first. Let's take this 1, 2, 3, and 1. So to the question by Varun, we are going through a problem called find peak problem. I'm going through the problem statement now. Like what exactly is the problem? I'll give you an explanation of it. I'll give all of you the explanation of this problem. Once you have understood it, then we'll try to figure out how to solve it. All right. So this is called find peak problem, where you need to find an element of an array such that it is greater than the element to the left of it and greater than the element to the right of it. It should be greater than both elements. Sounds simple, of course. So far it sounds simple. I'm going to give more and more conditions ahead. So here 3 is greater than the element to the left of it as well as to the right of it. So I need to return index where 3 exists. So what is the index of 3? If you observe 0, 1, 2, and 3. Index of 3 is 2. I'm supposed to return 2. Now, the question also states that you can have multiple peaks as well, like this 1, 2, 1, 3, 4, and 3. So in this case, we have 2 peaks. Whenever you have multiple peaks, you need to return index of any one of the peaks. So index 0, 1, 2, 3, 4, and 5. We can either return 0 or 4. Both will fulfill the test cases. That's how it works. So let me quickly state this down to you guys. So the question is like this. Find peak element. Peak element is identified in such a way that it should be, okay, it always should be greater than neighbor elements. That's the whole idea. Now, certain conditions are given. First condition, in every input array, there is at least one peak element. So you can never find something which is not available. So one more question, is it local maxima problem? Yes, you can think of it something like that. It is very, very similar to what we call as a local maxima problem. Absolutely right. So we don't need to necessarily find global maxima. A local maxima is enough. So that's the idea. Sometimes local maxima is not enough, but in this case, it is enough. So second, whenever there are multiple peaks, you can return any one index of the peak element, any one peak index. That is the second scenario. The third scenario, or the third condition that they give, no two consecutive elements are ever same. This is one more scenario. Now comes a confusing question, right? Now still when we look at all these scenario, now comes a confusing question as well. Let me put up the confusing question to you guys. Now in this scenario, if I have 4, 3, 2, 3, 4, now which are the peaks? Now it becomes confusing. So the question also states that the leftmost element you can consider it as minus infinity, and rightmost element also you can consider it as minus infinity. So it says that the index, the value of index minus 1 can be minus infinity, negative infinity, and value of index n can be negative infinity as well. Given there are n elements exactly, these are the conditions. And there's one more important condition which I'll give you after finding the solution for this. Now let's take a simple problem. Let's take a simple problem here. Should we return the index? Yes, we should return the index of the value, not exactly the value. We should return the index. Now take this scenario. If I have something like this, 1, 2, 3, 2, 4, and 5. Now, which are the possible indices I can return? Can you guys think of it? I'll write the indices on top. Now, which are the possible indices you think we can return? 0, 1, 2, 3, 4, and 5 from all of these. Think of which are the peak elements here, and you guys can let me know according to that which indices we can return. Let's see how many of us can get it right. So I'm getting a lot of different answers. All right. So here I can definitely say index 0 is not the peak, because remember, to the left of it there is minus infinity, to the right of this also minus infinity. But can I consider this as peak? It is greater than the element to the left of it, but it's not greater than the element to the right of it. Index 1, whatever value you have, that is greater than, it's not greater than the right. So we can only consider index 2 as our first peak. It is strictly greater than both its left and right element. So index 2 I can consider as one peak. So I can return this. Once I find this as peak, should I even go further on? No, because according to the question, when there are multiple peaks, you can return any one peak index. So I don't need to search further. We don't need to go ahead and search for more peaks ahead. I can just return index 2 and that's done. End of the program. Or on the other hand, if I have something like this, 3, 4, 5, and 6. In this case, the peak element is at the end. So what is the time complexity that we can get? Can you guys think about it? And one more thing I'll just point out, throughout this program, we have ensured that you guys can find it very easy and simple enough to work with. That is why we are making it an interactive session. So throughout the program, if you guys find any questions or have any doubts, feel free to put it in live chat. I'm here looking at the chat throughout to answer any question that you may have. So, as all of you have said, absolutely right. The worst time complexity, as Vamsi and Varun has pointed out, and as Sakshi has pointed out as well, is big O of n. This is the worst time complexity because we need to check for every element if it's greater than its next element. So we'll check it for index 0, 1, 2, 3, 4, and 5. We will only find that value at index 5 is peak because it is greater than the element to the left of it and the element to the right of it. But I haven't given one extra condition yet. This is what changes our entire logic. Till now the program was clear. Till now the program was easy. We could simply take it up. We could simply take it up in the problem we did here. That is, I was stream and let's say using namespace standard and int main, and let's just use return 0. We can easily solve it in the way we just did. We can search if, remember this is the logic, if our first element, that is if array of 0 is greater than second element, can I say it is a peak? If a of 0 is greater than a of 1, can I say it's a peak? This is my first condition. Can I do this? Because this element is of course greater than minus infinity. If it's greater than a of 1, that's enough. This is one condition to find peak. Second condition, if a of n minus 1 is greater than a of n minus 2. This is one condition. Third condition, what if there is only one element? If there's one element only in my array, that itself is the peak. Because if you guys observe, even if you have minus 32,768 or something like that, it is greater than minus infinity to the left, it is greater than minus infinity to the right? So it must be the strictly greatest element to both. So when there's only one element, we can directly return 0. That's it. A of 0 itself is the peak element. Now these are the conditions we need to work through. Now in question, if they say that there will be minimum one element, you only need this condition. If they say in input there can be 0 elements also, you need to find the size of it. If the size is 0, you need to return minus 1 or something like that. That will also be given. But in our condition, let's put it in the question that there will be one element at minimum. Now, as one of you, Sakshi, pointed out, can we use binary search also? That is where our most important question comes up. You should solve this in big O of log n time complexity. It's not you can, you could, you would. It's none of that. It is you should. That means they will only accept it if you do this. I have one more question. What if it's a 2 element? If it's 2 element, simple. You're doing this condition, right? Like 0, let's say you have 1 comma 2. There's more than one element. You start searching from first element onwards. Is first element greater than second? No. So take second element. Is it greater than first and third? If there's only 2 elements, you only need these 2 conditions. If not, you need every condition like this. But going ahead, I hope that clears the question. But going ahead, our question, our solution should not be big O of n. What we did right now was brute force technique. What we did immediately now is brute force technique, and we can do that. But the question says you should solve this in big O of log n. Now, when can we solve a big O of log n with binary search? If it is sorted, right? Only if it is sorted. What if it's not sorted? Can I solve it in big O of n? If it's sorted, I can try to figure out something like this. I don't know what is the logic. If it's not sorted, we can't do this. We have to go left to right. This is where a lot of students give up on this problem. This is where a lot of students feel like, you know what? I have to search every element with its next element. There is no other logic. And students don't try to think with other logic. A lot of students don't try to figure out different scenarios to solve this problem. And they just give up on this problem. And this is where we get this particular solution. Never. So we'll just end up not solving it whatsoever. But we're not gonna do that. We're not gonna give up that easy, because we want to get selected, right? We want to make sure that we are probably the first people to get within the interview to be selected. So what we're gonna do here is try to go through and see how we can solve this. Now, I'm gonna give you guys a solution here. All right. I'll explain the solution first to everyone. It's not going to be sorted always. All right. So that is one thing. So I'm going to explain the solution once to you guys, and then we will go ahead and solve the problem. So the way we're going to solve it, the way we will work through and solve it, uses a particular concept called invariant. You may not have heard of this particular concept till now, but it's a simple concept. We call it invariant. Let me explain what exactly it is. If you Google something called invariant in programming, if you just search it out, simple logic. Variant means something that varies. Invariant means something that doesn't vary. So we have something like this loop invariant code. Different people call it in different ways. All right. I'll just give you an introduction to this so that you can understand what it is. So the idea here is something will always remain same throughout, and it helps us optimize the compilers and everything. Once I do the program, you'll get to understand this even better. So it's something that does not change, does not vary, and it helps our code perform computations quicker. So we're going to use some concepts of invariance within this. So let me explain how exactly we're going to do. All right, let me explain the logic here. Let's take this same example as we had before. Right, now please observe and understand this very, very carefully. Now this is where I'll repeat, a lot of students give up on this sort of program because they think binary search works only if sorted. If not sorted, I can't do this. This way I'll give up. But we're not gonna do that. So I'll explain logic. I'll explain the logic. We're gonna have two values. One is called left, another is called right. Now remember this much. Left value will initially be 0. Right value initially will be at the last index. Alright. Now throughout the problem solution here, throughout this logic explanation that I'm going to do, if you guys have any questions, feel free to just put it in chat and ask. Because if you're able to solve this problem, then you've got a very good chance of solving such questions if it is ever asked in your interviews, right? And it's something a lot of us find difficulty in. So that's why I'm kind of repeating it, because a lot of students found it difficult. Last time a very similar program to this was asked. So here's the question. Here's the invariant that we will use. Remember guys, the invariant we will use is pretty simple. In our case, this is the array. Array of left minus 1 should be lesser than array of left. And then similarly, array of right plus 1 should be lesser than array of right. This is the constant code that we're going to use. I'll explain in detail what exactly it is. Or instead of right plus 1 lesser than right, if you're a little confused with this, you can also write array of right should be array of greater than array of right plus 1. Now you may be confused, like how will this help? Like this, sir, this thing what you're doing doesn't help whatsoever. Like how will this even help? You'll understand here. So it means that in our current interval, whatever our current interval could be, this is our current interval. In our current interval, what we are doing here is a pretty simple logic. That is, we are trying to find left and right indices by increasing left and decreasing right, such that we fall into three categories. I'll give you guys what are the three categories here. So I'll explain this. Once you see an example, you will understand it perfectly. Don't worry. So the first condition is array of left. This is our invariant. This should always be true. Along with this, we're going to give three more conditions. That is, along with this, array of left should also be greater than array of left plus 1. Array of right should also be greater than array of right plus 1. Those are two conditions. And similarly, the rest, whatever we have it from our entire line of code that you can see on the screen. So array of left should be greater than array of left plus 1. We already know from this statement, please note, we already know from this statement that array of left is greater than array of left minus 1. Since we already know that from here, I don't need to compare if array of left is greater than array of left minus 1. If it is greater than left minus 1, we don't need to compare again. So we only need to compare if it's greater than left plus 1. That's all we need to compare here, because one statement we have already done. So once that is done, we will increase from left to right. We will keep increasing from left to right until we find that left is a peak. Similarly, we'll go from right to left and we'll keep decreasing the right value. We'll keep checking if array of right is greater than array of right plus 1, and array of right should be greater than array of right minus 1 also, and we'll keep decreasing right one at a time. And in this, we're going to use a while loop, not a for loop. We're going to use a while loop in short to do this. Now, here's how we're going to work through it. Here's how it's going to work. Just remember, there's at least one peak for sure. We know that there's at least one peak for sure. So, according to our logic, left is initially 0, right is initially length minus 1. We already know, I'll repeat, we already know left minus 1 is minus infinity, right minus 1, right plus 1 is minus infinity. So these two values, whatever we have here, are greater than it's -1 and +1. So we only need to compare it with its next values over here. So what we're going to do initially is we'll start at every step of the loop. We will repeat this step. We'll repeat this step and we'll find mid. Again, we need to do login, right? So whenever we do login, we need to keep finding mid. Until we find mid, we cannot have one question while left less than right. Yeah, less than or less than equal to, we'll see the difference here. How exactly we're going to do. Is it less than right or less than equal to right? Because there are two scenarios that will come up. So we'll see which one to go for. Because depending on our logic, either one of this could be correct. Okay, so I'll take this, I'll just change this scenario since this is a larger question for our easier understanding. Quickly, for us to understand very quickly, I'm going to take only 4 values. Let's take this 0, 1, 2, and 3. I'll take something like 2, 5, 6, and 3 so that there's a peak somewhere in the middle so that we are moving more so that we can find the peak somewhere in the middle. That's why I'm doing this. All right. So let's take this scenario. You can take more elements later on and try it out as well. But we just want to understand the logic. So at every step of the loop, we need to consider that we have a mid value. And along with mid value, we need to consider 2 cases. That is, mid should be lesser or mid should be greater. According to that, we need to do certain, let's say, operations. So let me show this in practice. Now, first thing I'm going to do is, along with this code, we got to know this already. So let me remove this. Now, till when am I gonna loop? That is my first question. So one of you have said while left less than right. Correct. You can do it like this, or you can also do one more scenario like this. While right minus left greater than 1. So are both same? This is the question I'm going to ask you guys. Are both same? Let's say left is 3, right is 4. Is left lesser than right? Yes. Is right minus left greater than 1? 4 minus 3. Is it greater than 1? They're not same. So when you use right minus left greater than 1, the logic is not same. You're skipping out one element in middle because that element is our mid which we're going to search. Remember, we're going to have 3 things: left, right, and mid. Now, you may ask one question: why do we need 3 elements? If we want to reduce time, we need to increase space used. That's the basic idea. So I want to reduce time, so I'm going to use increase space. So I have one question: why right minus left equals 1? Why right minus left greater than 1? Once we go through this, you'll understand it perfectly. For now, just remember the condition here I'm going to use is while right, I'll just change this. Left, so that I can move them easily, because it'll be easier for me to move them so that I don't have to rewrite them, and we can save more time as well. Alright, so while right minus left greater than 1, I'll explain this because we have a mid value which we'll search. When I say this immediately, it may not make sense, don't worry, but I'll explain it in time. Now, first thing I need to do is calculate mid. As long as this condition is true, I need to calculate mid, and here's how we're going to calculate mid. Mid value, how do we generally do it? Left plus right by 2, right? Left plus right divided by 2. This is what we're going to do. But I'm just going to make one small change. Left plus right minus left by 2. This is what I'm doing. Don't worry. If it's slightly confusing right now, don't worry. All of this is to make sure that our program is the fastest program in the entire system possible. For that purpose, we are making all these optimizations. I'll explain each optimization in detail. You can use such techniques in other programs as well. So this is our first thing that we're going to do. So let's calculate mid. What's the mid value? Left plus right minus left by 2. Left is 0. So 0 plus, what is right minus left? 3 minus 2 is 3 by 2. 0 plus 3 by 2, we get it as 1.5, which becomes 1. So we immediately get to know that our mid value is 1. This is our mid value. Done. Now, once our mid value is here, now the next thing I need to check is whether to move to left or whether to move to the right. So I need to check if my mid value is lesser than the next element or is it lesser than this element, because your value whichever is called mid can either be the perfect element which you're supposed to return, or it can be, on the other hand, I'll repeat, it can be the peak element, or it may not be the peak element as well. So here's what we are figuring out. Is it the peak element? It's not. Since it's not the peak element, we're going to give this particular condition here. Please observe. If it is peak element, we'll return it. If you can say like array of mid, whatever you have, array of mid is greater than mid plus 1 as well as mid minus 1, you can return it right away. You don't even need to worry. Otherwise, if it's not greater than both of these cases, if it's not greater than both of these scenarios, then we need to move either to the left or to the right. Now, why am I moving here? This is the logic why. Think of this, guys. We need to find one peak, right? We need to find only one peak. Think of this. If I have 1, 2, 3, 4, 5, and 6, if this is the middle element, if the right element is greater than it, somewhere it must stop, right? Because here we are having lesser elements. Here we are having greater elements. When I move to the greater element, there's a chance I may find an element lesser than it also. But when I move to the lesser element, there's a chance that I may move till the end and all values are lesser than it itself. So you can move either direction. But if you keep moving to the left and every value is lesser than it, will I get a peak anywhere? No. If you keep moving right, if every value is greater than it, you can still get a peak because 6 has minus infinity next to it. So it will be a peak. If 6 is not a peak, if something else is peak like this, you can still get a peak here. So why am I moving to the side where larger element is there? Because wherever there is larger element, there will always be a peak. Wherever there is a lesser element to the left, there may not be a peak. Take this scenario. If I take let's say 5, 6, 3, 4, 4, 3, 1, and minus 1. Now, if this is my middle element, to the right of it I have an element lesser than it. Or let's say this is my middle element. To the right of it I have an element lesser than it. Since it is lesser than it, can I find any peak? Is there any peak? Is 3 greater than its next two elements? No. Is 1 greater than its next two elements? No. Is minus 1 greater than its next two elements? No. So am I able to find a peak in the side where I got a value lesser than the current element? What do you think? Are we able to find a peak if we move to the... No, it's not compulsory that the array is sorted. Your input array can be unsorted as well. It could be unsorted as well. So I hope I'm audible very clearly in this case to everyone. So to Vamsi's question, mid is not peak, because remember, is mid greater than its neighboring elements? Is 4 greater than 6 as well as 3? No, right? It's not. So you cannot consider that this is your peak. I hope that is very, very clear. We cannot consider that this is the peak. Peak should be an element which should be greater than its left as well as right element. So from peak, from mid, which direction should I move? Should I move to the left or to the right? Rather than that, let me ask you a question. Why should I not move to the right? Can you guys let me know? Why should I not move to the right side? Think through. Why should I not move to the right side? Yes, there will be no maxima value over there. That's why we're not going to move over to the right. Simple logic, very simple logic. Whereas on the left side, there's a chance and there's a guarantee that there will be a peak. because here we are looking at the worst case scenario. In worst case scenario, right as BP and 1C both pointed out, there's absolutely no guarantee that we can find a peak where we have a lesser value, but we can definitely find a peak where we have a greater value. Because if 6 is greater than 5, when you go here, this is peak. On the other hand, let's assume this is not peak, then this value should be greater. So if you go here, this is definitely peak, because here you have minus infinity, here you have 6, 7 is greater than that. This is the logic we are thinking of. This is how we are gonna move. This is how we are gonna make the movement. Now, once we find mid in our case, so let me ask you guys, do you guys want me to execute this in our simple binary search logic first and then optimize it, or do you guys want me to directly give you optimized solution? If you guys want me to go through the binary search method first and then optimize it, we'll do that. So if you find it slightly difficult, optimizations and everything, we'll do binary search method first and immediately convert that code over. I have one question. What if all the elements of the arrays are same? Look at the condition here. There's one condition, condition number 3. No two consecutive elements are ever same. So you cannot expect all elements to be same. That's one thing we can be sure of. And let's try this out. Okay, binary search is what everybody wants me to go through. All right, let's give this a try very, very quickly. Now, first thing, I need to read an integer n, and I need to read n elements. To read n elements, I'm going to use vector. For those who don't know, for those who are new to this, vector is a resizable array. It is an array which can automatically be resized. You don't have to go through malloc, calloc and everything. It will resize automatically. That's the only difference. So I don't want to create an array of n elements myself. I will create an array using vector which will automatically change its size. So I need to create a vector of integers. To do that, I'll create vector of integer and I'll call it array. Why am I not giving a size? Because our vectors are resizable. They will change the size according to the requirement. So every time I enter an element to the end of this vector, it will increase its size automatically by 1. So let's first read n value. After reading n value, we need to read n elements in vector, right? So I'll take something like int temp here for our reference. So for I equals, we need I as well. I'll also take temp as well here. So what I'm going to do here is for I equals 0, I less than n, I plus plus, I'm just going to take int, c in temp. After reading in temp, I'm going to take that variable called temp and I'm going to push it onto our vector. I have a function called pushback. If I use this function called pushback, whatever element is taken in pushback, it will be stored as the last element of the array. So when I equals 0, first element pushed is the first element of our array. When I is 1, second element pushed becomes the second element of the array. When I is 2, the next element is pushed is the next element of the array, and so on. You may say this is not efficient. Why are we storing in a separate variable and adding here? Because in interviews, if you get a separate function program, in the function they will read it as a vector. They will not read it as an array. In a function in C++, it will be read as a vector. So if it is read as a vector, you need to find out how to read values from vector, how to work through vectors. That's why I'm doing this. All right. So after this, if you want to print all the values of vectors, for those who are new to this, you can just use the same for loop and you can just print here array of I. Same way as arrays you can access. There's absolutely no difference. So I can just compile this. Let's say code.cpp and let's execute this. I'll give 5 elements. I'll enter 1, 2, 3, 4 and 5 and it gives me 1, 2, 3, 4, 5 values as expected. So this is how vectors work. I hope the logic is simple. Now what we're going to do here is call a function called findPeak where we're going to send our vector. That's it. We're only gonna send a vector. We are not gonna send number of elements because in interviews you will only receive vectors without its size. We'll have to see how to find out its size as well. So let's create this function. Int find p of a vector of type integer is what we're receiving. Remember, we're receiving a vector of type integer. That vector of type integer, whatever is array, we're going to receive it with same name, array. That's it. Why am I using ampersand here? It's called a reference variable. So for those who are new to C++, you can just check out what are reference variables. You can get an idea of it. It's similar to passing by address, similar, but it's not exactly the same. You can get a look at it. All right. So it's pretty easy to work with. Now, here's what we need to do. Remember, it needs to send a result which we are supposed to print over here. So this is our find peak function where we are supposed to find the peak element. After finding the peak element, yes, it is or not base address exactly. Um, a reference variable is just like an alias name. It points to the same array. It's just a different name. That's it. You can change the name here if you want. But a reference variable is just another variable name which points to the same previous value. That's it. So let's go ahead here very quickly. It's just another name for the same variable. That's all. And let's try solving this. Now, what's our first condition? We need to find the size. To find the size, you can just use array.size function. Now, vectors have an inbuilt function called size with which you can get to know what is the size of an array or size of a vector. Now, if size is 1, what should I return, guys? What will be the peak index? Can you think it through? Think it over. If size is 1, yeah, it's just like one thing, two names, similar. Absolutely right. If size is 1, we're supposed to return 0 because there's only one element. It is greater than negative infinity without a doubt. So we have to we have to return the exact same value. Now, on the other hand, we have two conditions which we are going to check right here. That is, if on the other hand, let's assume we also have 0, then we return -1. But according to the question, it said that there will be one element at minimum, so we don't need to worry about that. This is if there's only one element. Now let's give the second scenario. If there is more than one element, there's two special cases. First element and last element are special cases. So we need to solve separately for first and last element. For first element, I can say something like if array of 0 is greater than array of 1, that means array of 0 is definitely the peak element. We can directly return index 0 here as well. So we can write here that is if first element is peak. Since in both of these cases we are returning 0, we can give an OR condition and combine them as well. This also we can do. But if you do this, you'll get an error because if n is let's say 1, we can, okay, this can basically work, right? We can do this. Now, on the other hand, what if there's only one element or first element is peak? Now, what if on the other hand, array of n is greater than array of array of n minus 1? Because if the size is n, indices go from 0 to n minus 1. I hope you guys can remember that. If array of n minus 1 is greater than array of n minus 2, we are supposed to return the peak here, that is n minus 1. So that is also done. Now we're going to start with our next case, that is int low and then int high, which we're going to use with our concept of binary search, where low will be index 1, high will be index n minus 1. Sorry, n minus 2. Now why am I taking 1 and n minus 2? Think of this. See, we have already checked for index 0. We don't need to check for it again. We have already checked for last index. We don't need to check for that again either. So we should start from index 1 up to index 4. So that is why we're going to start our low value at index 1 and our high value at index n minus 2. Because 0 and n minus 1 we have already checked it in this scenario. Now that is why we are going from 1 to n minus 2. Now our condition is as long as low is less than equal to high. As long as we are not crossing the limit. As long as low is either equal to high or less than high, we're going to keep repeating this. Let's see how to do this. First thing I need to calculate, I need to create a variable called mid. Let's also do that. So our mid variable here will have simple logic. We'll be having low plus high by 2. Simple. Now what is low plus high by 2 here? 1 plus 4 by 2. So 1 plus 4 will give you 5. 5 by 2 will give you 2.5. Since we are storing it in an integer, we'll get 2. So we'll get 2 here. Now assume that, guys, sorry, I'm going to have to change this question here. In that case, I'll have to make something in the middle as, let's say, a peak. So we've got this as the peak instead. All right, so that we can figure out this solution. So first thing we do is calculate mid. Now remember, in our case, mid will be 2 because 1 plus 4 by 2 gives you 5 by 2, which basically gives us 2.5, which ends up being 2 as an integer. Once you find out mids, you need to find if your mid element is the peak or not. We just need to check if array of mid is greater than array of mid minus 1. Sorry, not mod minus 1, guys. It's array of mid minus 1. And the other condition is array of mid is greater than array of mid plus 1. If both these conditions are true, what do we do then? We just return mid. That's it. We just return mid and exit because we know there is some particular mid value somewhere. It definitely is there. So we just exit. If we couldn't find it, we need to either increase mid or decrease mid. Under what condition do I increase mid, guys? So under what condition do I, let's say, increase low? I need to increase low under one condition, else I need to decrease high. Under what condition will I increase low? Can you look at this and let me know? Here we have to increase low, but what is the condition? The condition is that if array of mid minus 1 is lesser than array of mid, then I will increase low. Otherwise, I will decrease high. That's it. So let's go ahead and check this. If array of, I have one question, max of mid minus 1 comma mid plus 1. Okay, let me check. Okay, one of you have given me a question. We can find max of mid minus 1 and mid plus 1. If array of mid is greater than max of mid minus 1 and mid plus 1, then I can do that. Yes, both cases you have two conditions. There you are comparing which is maximum and then doing the second comparison with mid. Here you are doing both direct comparisons with mid. Either way, you need to do two comparisons at minimum. A nice idea at Deepti's question, really good idea. But in both cases, you need to do two comparisons minimum. So it really doesn't make much of a difference. So let's go ahead in this case. If array of mid is greater than array of mid minus 1, we increase low, otherwise we decrease high. That's it. This is your entire solution. So in this case, we increase low. After we increase low, we have to calculate mid again. When we calculate mid, our value is mid equals low plus high by 2. That will give us 3 plus 4 by 2, that is 7, which will be 3.5, which ends up being 3. Once it ends up being 3, let's take one more scenario. Let's make it even more complicated. Let's do it like this. Once it is 3, I'll get mid value as 3. Now, once mid is 3, we'll do the same thing again. Is mid greater than both elements? No. Since mid is not greater than both elements, is mid greater than any one? It must be greater than any one, right? Because according to our input condition, according to our question, no two consecutive elements will ever be the same. So our current value must be greater than one value at least. So our mid value here should be either greater than previous or greater than next. Since it is greater than the previous value, we're gonna calculate mid again. We're gonna, since it is greater than previous, we're gonna increase low. When we increase low, low and high both become equal at 6. Now we're gonna calculate mid equals low plus high by 2, which is exactly 6. So how many comparisons did we do here? 3 exactly. So same as binary search, since we have less elements, it's difficult to understand. If we had something like 20, 30, 40 elements, you guys will understand how low, mid and high will move easily. But I hope you guys can easily understand even in this scenario. Now let's take a scenario. Let's take a case here. So what's the value of mid this time? Index 4. Is index 4 greater than the other two? Yes, it is. Since it is, we're just going to return mid. That's it. This is our entire program. So let's try running this. Let's compile this. We will get one particular warning. That is, um, let me show you the warning over here. Very simple. It will tell you one warning. That is line 24. The warning it says is you're not returning anything. You're returning non-void function. That means it says you're not returning any value because we are returning all values under condition. We know it will work perfectly, but we are returning under condition. That's why it may give that error. To avoid that, you can use break here. If this is the condition, exit from the while loop, then return mid. So to avoid that condition, you can use break and return mid here. Let's see if it works. Let's compile this. There shouldn't be any warning. Let's run this. I'll give, let's say, 5 elements like 1, 2, 3, 4, and 5. Index 4 has the highest value. Let's give 5 elements 4, 3, 2, 3, and 4. Is this correct? I have one question. Are all elements unique? No, you can have repeated values, but they cannot be in continuous elements. You can have repeated values which cannot be consecutive elements. Is this correct? Yes. 4 is greater than its next element. That's it. That's enough. No need to worry about it. So this is how you can figure out. Let's also try a middle element. Let's quickly give it a try. 1, 2, 3, 4, 6. Sorry guys. First let's give 6 elements. 1, 2, 3, 6, 5, and 4. Now index 3, which is 6, has the right element. So this is your code. I will be giving you guys this particular code here, and what I want you guys to do is scratch your head a little today and try to find out if you can optimize this. There's a way to optimize this. Try to see if you can optimize this. It's not the perfect code. It works well. We may assume that this is the perfect code, but there are small minor optimizations which we can do to make this program slightly better. So I want you guys to scratch your head a little, try to struggle a little till tomorrow and try to work this out, because tomorrow I'll give you the solution for this. So by then we'll just share the link of this program to you guys. So until then, you guys can let me know if you found this program interesting, easy enough right now, or like if you're able to understand with this logic, and so on. So you guys can let me know if you find it easy, difficult, however it is. So we can also get to know that you're able to know. So yeah, somewhat medium difficulty, right? It is not an easy program. It's somewhat of a medium difficulty program, and this is a good logic to work with it. Absolutely right. So glad that you guys are able to work through it and understand it. So I have one of you asking, take more star pattern problems. All right. So if you guys want me to go through certain star or pattern programs more, we can think and plan through. Okay, I have one of you asking a Python code for hollow diamond. Okay, I haven't shared that. Let me also share that as well. I think I have forgotten to share that. I'll share all Python, not just Python, Python, C++, and Java, all hollow pyramid programs together for you guys so that you can access this. So guys, I'll just share a link here. So one of you have stated that you want us to go through more pattern programs. So I will definitely take a look at other kind of pattern programs that are generally asked, and whichever seems to be of medium difficulty, which are generally asked for TCS and Infosys. I'll definitely take a look into that and I'll share that to you guys. All right. So at Deepti's question, it will be done. Not to worry. All right. So with this, we'll end our session here today. I hope you guys had a fun time going through this new kind of program where we work through binary search, or we work through binary search to find peak element without an array being sorted. It's sort of a new kind of problem which most of us may not realize immediately unless we realize where to go to find a peak element. If we don't realize that, we just end up thinking like, you know what, it's going to be a big of n problem only. I won't be able to do it. So I hope this gave us a good idea on how to do this. With this, we'll catch up tomorrow and work through more problems. Have a good night, guys. And I have one question. So there's some cracking of voices. All right, I'll definitely give a check through my mic and see what I can do. Because I generally end up increasing the decibels of the mic to ensure that it's audible. So if it's catching up more noise, I'll definitely give it a check. Not to worry. All right. So with this, we'll catch up tomorrow. Do try the small little thing that is to make our current program even better. Let's see if we can do it. If we can't, I'll definitely help you out tomorrow. All right. So with this, we'll end our session today. Have a good night. See you tomorrow, guys.